Hello participants. Now we are starting a new topic of the subject on micro irrigation engineering. This new lecture is on irrigation methods. We discussed in previous classes on basic fundamentals of fluid mechanics. We discussed about soil plant water relationship. We dealt about irrigation scheduling. There we discussed about, in irrigation scheduling we discussed about how to schedule irrigation and what should be the depth of irrigation. So, the next part of this thing, when we would know amount and timing of irrigation and how to apply irrigation water. This is equally important because whatever water we are giving, it should be made available to the plants as maximum as possible, so that the water is stored in the root zone depth. It can be used by the plant for meeting its evapotranspiration requirement. So, in this particular lecture on irrigation methods, we will deal with different types of irrigation methods. We will also deal with hydraulics of surface irrigation methods and relative comparison among these methods. As we know that contribution of irrigated agriculture to total agriculture production in India, it ranged from 55 to 60%. And if we are interested to use this water effectively, so that contribution of irrigation water, it can bring more area under irrigation. And as far as our studies say that overall efficiency of existing irrigation projects, the application efficiency, irrigation efficiency of these projects, it ranges from 30 to 35%, whereas the ideal projects which has reported that yes, we can achieve irrigation efficiency up to 50%. So, it is the irrigation method which will play important role in order to get higher irrigation efficiency. We know adequate water supply is important for the plant growth, and when rainfall is not sufficient, we need to give irrigation to meet its requirement. Now, there are different methods of application of irrigation water, and these methods have its own advantages and disadvantages. And then the selection of a particular method depends upon the local conditions available there, means type of soil, type of crop to be grown, and then main thing is economic status of the person who is adopting a particular method. So, irrigation water can be applied to the crops by flooding the field, we can say by flooding the field, or by applying water beneath the soil surface means the water will come from the beneath the soil surface by controlling the water table, or supplying the water under pressure, that is a pressurized irrigation, or by applying water in the form of droplets, that is by drip irrigation. So, when we broadly classify irrigation methods, we can put surface irrigation, sub irrigation, sprinkler irrigation and drip irrigation. As the name said that surface irrigation means water is applied over the land surface. So, overland flow takes place on the soil surface. When we say sub irrigation means we are giving water beneath the soil surface and then water comes to the root zone of the plant. So, this is a sub irrigation. When we say sprinkler irrigation system means we are applying water in the form of spray by creating adequate pressure by using appropriate nozzle, and then from the nozzle water is sprinkled in the form of spray, and then it falls on the ground surface, it falls on the leaves of the plant also. And when we say drip irrigation means we are applying water literally drop by drop. So, let us go for each of these 4 methods which I have told in little more detail. So, coming to the surface irrigation, then in the under the surface irrigation there are 3 broad methods. One is border, another one is check basin, and then third one is furrow irrigation. So, these border can be straight border, we will discuss in detail. So, let us just know that their classification. The border can be straight border or contour border. Similarly, check basin can be a rectangular in shape, or it is laid on contour, or it can be made a ring circular, means the basin can be a circular in shape. And then a furrow irrigation can be a deep furrow, looks like a channel, and then the crop is grown on the ridge. Or it can be a shallow furrow, and where the just by running a smaller depth of water is supplied. So, that is it could be. So, deep furrow can be straight or contoured, means straight when the slope is not, means land slope is within the permissible level, then limit, then straight furrows are used for irrigation. If land is having it is a sloping land, then the furrows are laid along the contour, or we can say across the land slope. Now, the straight furrows can be, if these are it can be laid long, then on level land it is simple, or if it is on little sloping land, then that slope can be truncated, and then one particular furrow can have 2 different slopes or 3 different slopes as per the requirement, and that length can be truncated, that is a graded furrow. Similarly, corrugated furrows could be a straight or contour. So, as I told that this could be straight, or these can be laid on contours. A sprinkler irrigation system, there are quite a big classification. We will, when we will come to the sprinkler irrigation particular lecture, we will go in more detail, but here just we can have, it means this could be a rotating head sprinkler system, or a perforated pipe where the water is spilling out in the form of a spray or a tiny streams out of the perforations made on the pipe, and these pipes could be made up of a metallic pipeline, aluminum pipeline. Now, slowly these particular perforated pipe systems are not adopted, because the clogging of or blocking of the pores are causing problems. So, rotating edge system is more prevalent in the field. And then drip irrigation system. So, there is a big classification, it comes under drip irrigation system, which also we call it as a micro irrigation system. So, we will go in detail in the coming classes. Now, here you can see these are all the methods which I have explained you. These are shown in these in this particular different photos. So, and this is scientifically designed. So, the way it is being displayed in these figures in these photos, it looks quite nicely it has been designed, but normally such design system in field you may not find that. So, in particularly in surface irrigation system. So, if you look at this particular the leftmost corner this photograph. So, here it is a furrow irrigation system. So, furrows are made in a systematic way and water is allowed to flow. And then if you come just below this on the left side. So, drip system, and on the drip online point source drippers are attached, and you are seeing that how the water is emerging out of the drip line. Below that you find that there is a surface irrigation system, and then for each individual plant or tree you find there is a ring has been formed. So, this is a ring basin ring this your ring basin irrigation system, which is also one of the way of means giving water as a in the basin irrigation. Then when we come to the means from the top, here what we are seeing, the water is coming out of a sprinkler nozzle. So, set up sprinkler nozzles, and then the aerial view of these the water sprayed from a sprinkler nozzle is being shown in a given landscape. So, this is a beautifully shown photograph. Then in this particular just below that we see here that here there is a furrow irrigation system. These furrows are laid across the slope. So, these furrows are laid across the slope, and so these are contoured furrows and irrigation is being given in this. And here what we are seeing, this is a subsurface, this is a subsurface drip irrigation system which has been laid, and then water is being you can see this is one subsurface drip pipe, this is another subsurface drip pipe, and then crop is a maize crop. So, a corn is being grown, and then how the water is spreading this one. So, the way root growth it is shown here. And then here we see this is a micro sprinklers which are put up in a crop. So, this is a micro sprinkler, this is the another the sprinkler irrigation system, pivot sprinkler irrigation system, and then here this is a furrow irrigation system, and the water to each furrows are given through a gated pipe. So, a pipeline where the holes are made, and these holes means they are connected with a another smaller pipe, and then each individual pipe is supplying water to the each individual furrows. So, pipes are connected. So, these are all photographs which are showing demonstrating the different types of irrigation methods. Now, coming more detail about the surface irrigation method. So, surface irrigation as it says that it is the application of water by gravity flow, means there is enough velocity is maintained through gravity flow. So, water moves over the land surface by using inertial force. So, it in surface irrigation system either the entire field is flooded. So, this could be a basin irrigation, or it can be a border irrigation system, or the field is the water is fed into small channels, which we call it as a furrows, or we are supplying water to strips of land, which we call it as a border. So, surface irrigation has advantage. It is a simple method. It does not need any expensive equipment, and therefore, it requires minimum capital investment. It is it does not need a very high energy or pressurized system. So, the energy cost means on the application of energy or power supply, it requires minimum. So, this is a low energy cost system. There are some disadvantages, that it is a less efficient than pressurized system, because the water is not smoothly reaching to all the points of system as we find in the pressurized pipe irrigation system. So, from application point of view, it is not efficient, and then lower areas or upper areas, they have their own problem. Means lower area, it gets flooded, so water logging, and then it could, when the water stagnates for longer time, the salinity problems it comes, and this is a common problem in majority of the canal commands, which we find that there was no problem as such when the commands, these canals were not operating, but after the canals have come and people started over irrigating, and then large area, because of the high water table, it has caused the problem of water logging, and soil salinity has become a problem. Land labeling is another important issue, and unless it is not labeled land, that all part of the field is not able to get adequate amount of water. So, which is an expensive item or expensive component in surface irrigation. It needs large flows to reach water at each point of the field, and water application is not uniform, means more water available at the head reach or upper reach of the field, and when as compared to the lower reach of the field. So, any surface irrigation system, whether it is a furrow irrigation, whether it is a border irrigation system, or it is a basin irrigation system, it passes through 4 basic phases. So, phase 1 is that is advanced phase. So, advanced phase means if you see the diagram here, advanced means the irrigation stream is introduced at the one end of the border or basin or furrow. So, water is introduced at this one end. So, when irrigation stream is introduced into the field and ends when water reaches at the downstream end of the field. So, it will continue to move toward the downstream end of the field, that is the advanced phase or movement of waterfront, advanced movement it is taking place. So, this movement of water when the irrigation stream is introduced is advanced phase. Now, when it reaches the up to the downstream end, so storage phase begins. So, storage phase begins when the A phase, that is advanced phase, ends, and it occurs only if inflow to the field continues after the advanced water has advanced to downstream of the field. Means as long as once we are close, means continuing the water supply. So, the storage phase will begin, and then storage phase means the build up of water level in the basin, in the furrow, in the border, it will continue. So, what we are seeing when the waterfront, when you are plotting a diagram. So, this kind of the advance curve will develop, and then when you are continuing, means this here it has ended. When you are continuing this water supply, then so there will be depth of water, it will increase, and then there will be storage phase. Now, Then when the third part is your depletion phase. Now, this is your storage, means there is certain depth of water which has accumulated over the land surface. Depletion phase begins when B phase, that is storage phase, ends. So, means we are cutting off the inflow. So, at the end, when the depth of flow at the inflow ends and of the field becomes 0. So, depletion will start, means the depth of water will start diminishing when the irrigation supply is cut off. And then what happens when irrigation supply is cut off, then recession phase will begin. So, the behavior nature of the recession phase in border irrigation system as well as in furrow irrigation system, this is the behavior of the recession. But recession in case of basin irrigation will be different, because once we are cutting off the water supply, the length of basin is not as long as furrow or border strip. So, this will be more or less the parallel to this particular axis. And so, when we are talking about different phases, the advanced phase as well as advanced means your distance of travel is plotted with time. So, advanced phase is represented by curve A. Let us say when there is a particular stream supply, it has been supplied, and then this is another advanced curve, that is a B curve. So, and then when we are plotting, so this is your advanced curve, this is one case, this is the another case, and this is your recession phase. So, means when there is a difference, we are seeing that in this is A. So, what happened, why this difference in the advanced curve could be? So, it could be because what happened, the advancement of the stream, it is slow, means it is going slow. So, what could be the region, means here one region that here the stream size is it matters, one is that stream size it matters, another one is slope is flat, that could be the region, or then another one is the infiltration capacity of the soil. So, infiltration capacity of the soil, this also matter, and third one is that the hydraulic resistance, means the either soil is newly plowed, it could be the region, there are clods, that could be the another, means the smoothness of the land surface is not there, or there is some crop which is grown. So, this affect the behavior nature of the graph when we are plotting. So, now the another point of consideration when we are designing any surface irrigation system, it is important that the amount of these two curves, when we are plotting these two curves should be as far as possible, they should be parallel. So, infiltration opportunity time, or we can say the time which requires the water to pond, it is uniform from one end to the other end, that is a theoretical consideration. So, at the upstream end there is a more means infiltration will be more, and as you go to the downstream end the infiltration is going to be the less. So, difference between the time of water, when we say infiltration opportunity time, so it is the difference between the time of water front reaches a particular point. Let us say this is the particular point, and the time at which tail water recedes from the same point is the infiltration opportunity time or time of ponding. So, it reaches a particular point. So, say this is the point it has reached, and then it starts receding from the same point. So, difference in this particular time. So, say this is one time, it could be a few minutes here when it has reached there, and then the when the irrigation stream is cut off, then it starts receding. So, this time difference, if you are taking it, so say this is T 1, this is T 2. So, T 2 minus T 1 is the time which was available for the irrigation stream to infiltrate, and this time is infiltration opportunity time. Now, what we are seeing that in a border irrigation system, because surface irrigation systems are, it could be a border irrigation, it can be furrow irrigation, it can be basin irrigation. So, what is a border irrigation? Border irrigation, in border irrigation system, field is divided into strips by parallel ridges. So, these are the, this is one ridge, this is second ridge, this is third ridge, this is fourth, means like this, these are the ridges. So, these ridges, they are parallel to each other, and then it has got certain height which guides the water to flow. So, means each strip is irrigated separately. So, water is supplied from this end and it reaches. So, this is the advancement of, means how the water, when the water is being introduced. So, this is the advancement of the stream. So, we call waterfront advance, and when irrigation stream is cut off. So, when it is a cut off, this start disappearing. So, this is your recession phase. So, these borders can be they are laid along the slope. So, we call it as a straight border, and when the means this particular slope it exceeds shape limit, the fields are undulating or leveling is not feasible, these borders can be laid across the slope, and these borders are called contour border. Here what we are seeing, the you can see here how the border specification is made. So, this border can be this is a width of the border, we can see here how they are given, and this is a prevailing land slope and this is the length of the border. So, normally width of the border it is from 3 to 15 meter, length it varies depending on the particular type of soil texture. So, it can vary from 60 meter to 300 meter. So, when it comes from the coarse texture soil to the fine texture soil, what we are finding that the length of the border is increasing. Similarly, the slope of the border. So, border slope it is varying, which we are seeing that for sandy loam soil it is a higher slope, because infiltration there is like chance that infiltration will be more in case of sand means coarse texture soil. So, slope is given more in case of coarse texture soil, and in fine texture soil slope is. So, this is the range in general it is adopted. Based on the research studies carried out by investigators, and they have recommended what should be the appropriate size of the stream for different types of soils, soils having different infiltration rates and then prevailing land slope. So, with the prevailing land slope, let us say that sandy soil having infiltration rate of 2.5 centimeter per hour, having slope between 0.2 to 0.4%, the irrigation stream size will be 10 to 15 liter per second per meter width of the border. 10 to 15 liter per second per meter width of the border. So, let us say that if the width of the border is say 15 meter, then irrigation stream size will be in that case 50 liter per second. So, we will select depending on the particular type of soil it is there, and then one can select the width the stream size. A hydraulics of border irrigation system, the flow in a border strip is a case of spatially varied unsteady open channel flow with decreasing discharge, means discharge is decreasing with space. it is true that when you are introducing a stream, what happened? Initially the stream size and part of this water will be infiltrating when it will so it will be reducing. So, part of water it will be reduced. So, it will be reducing the stream size when it will go further, it will advance further. So, what are the different variables which influence the movement of water, advancement of waterfront? It will depend upon the what is the size of stream, it will depend upon the slope of the land, it will depend upon the infiltration characteristics of the soil. Of course, that is a type of soil rather we can say, and then the resistance to flow offered by soil surface and vegetation cover. So, how does what when I was telling that when the water is being supplied to the border, so how the infiltration. So, infiltration what you are seeing at the upstream end, it is taking place more as compared to the downstream end. So, this is the place where infiltration. So, this is uneven distribution, and when it is not properly designed, you may find that at the upstream end the water will go more deeper, and then at the downstream end. So, the behavior of the water infiltrating below the soil surface from the upstream end to the downstream end of the border, this will be the infiltration trend. Check basin means dividing the field into smaller units. These are the means in case of border it is a long strip. Here this strip is divided into number of each smaller unit areas, so that each unit has nearly level surface. So, bunds or ridges are constructed around the area forming basin within which irrigation water can be given or controlled. So, basins are filled to the desired depth and water is retained until it infiltrates into the soil. Basin irrigation is adopted normally in land having gentle slope, and it means basin normally this is used for close growing crops, mainly for the rice, jute, these crops, it requires more water for ponding. So, basin irrigation is very means suitable for such crops. Of course, other crops can also be grown, and particularly ring basin irrigation when it is to be given, that is used for wide spacing crop for orchard. So, especially means this particular method is adopted to irrigate grain, fodder crops in heavy soil where water is absorbed slowly and is required to stand for a relatively long time to ensure adequate irrigation, depth of irrigation. So, you are seeing here this is a ring basin irrigation. So, water is given in the ring and then remaining area in between one tree to the another tree, that is dried, that is remain not irrigation is not given. Here what you are seeing, this is a rectangular basin, and then these are the temporary bunds, so that the water cannot spill over from one end to other end, but so considerable amount of water it is used for infiltration as well as the land is also it gets wasted when we are giving. So, in case of basin irrigation system, water covers the basin rapidly to ensure good uniformity. There are some disadvantages. Now, these disadvantages are there. These ridges, it interferes movement of equipment when interculture or harvesting operation is done, and it requires land grading, shaping of the land. So, that is the one essential requirement to apply uniform depth of water in each smaller unit areas. Labor requirement is high for making these ridges if it is made manually, and considerable area is lost due to formation of ridges and bunds. Hydraulics of check basin irrigation system, it is the same, more or less same as border irrigation system, means irrigation water when it is introduced. So, what happens, initial water will is spreading the intense means it is spreading to cover the full width of the basin, and then the horizontal as well as the lateral movement of water takes place. So, advancement of waterfront after the initial phase spreading it takes place, means after the lateral movement initial, then the advancement of water it takes place. And then rise of water level when the irrigation stream is continued for some longer time, then what happen, when it has reached to the downstream end, there will be rise of depth of water, and then after it has reached an irrigation stream is cut off, then subsidence of water level will take place. So, there are 4 phases, and when you are plotting a graph, let us say this is your advance curve, and then when the irrigation stream is cut off, then recession stops. So, since the length of basin is small, so recession curve when we are drawing, it is a parallel curve to the x axis. So, infiltration opportunity time in case of basin irrigation is not uniform as compared to the furrow irrigation. So, furrow irrigation is another methods of surface irrigation, and here furrows are developed between the crop rows, and the size and shape of furrow. So, what you see, this is the one furrow, this is also a furrow, which is one is constructed in sandy soil, another one is constructed in clay soil, and the spacing between furrows means here the crop is grown on the ridge, here the crop is grown and furrow, these are the smaller channel, but we see this is the smaller. So, when say if it is grown furrow is made in sandy soil. So, what we see, the spacing between the furrow, if it is too wide, then what happened, the water which is moving in the lateral direction, the movement of water will be lesser. So, part of the area will be dry. So, that is not advisable to use wider spacing in case of sandy soil, whereas these furrows when it is the spacing is adopted in clay soil. So, what we see that the water movement in the horizontal as well as the lateral direction it takes place. So, the plant in this ridge is getting adequate quantity of water. So, in case of furrow irrigation system, horizontal as well as lateral movement of water it takes place, and these furrows are also used for disposal of runoff water. Furrows are used for row crops which are grown, say maize, sorghum, sugarcane, these are the crops, and it is well adapted to irrigating crops which are subject to some crops which are subject to injury due to ponding conditions. So, this is and root rotting takes place. So, it is better to use furrow irrigation system, and when there is a problem of the soil is sandy soil, in that case one should be careful about deciding the spacing between the furrows. And you can see here this is the furrow irrigation system, where these are all the straight furrows which has been drawn, and they are best suited when the land slope does not exceed 0.75%, and when they are laid across the slope, these are the contoured furrows. So, these are beautifully, it is you can see these particular the photos which are showing how the furrows have been made and then crop is being grown. Furrows, why furrow irrigation is recommended in surface irrigation, when means the total area which is coming in contact with the water, it is just only half to 1/5 of the land surface. Therefore, it is reducing the puddling and crusting of the soil. Earlier cultivation is possible because part of the area it is remain dry, and then it reduces the labor requirement in land preparation and irrigation compared to check basin method of irrigation. In order to evaluate the infiltration takes place. Normally, infiltration test it is done when the water ponding takes place in case of basin irrigation or in border irrigation system by using the double ring or single ring infiltrometer. But in case of furrow irrigation system, since water is in dynamic condition, so inflow outflow method is recommended to use for finding out the infiltration rate. So, in this case when we are evaluating the infiltration through furrow irrigation system, so we use inflow outflow method, and in this particular method furrow is divided in number of sections, and at each sections the water is measured using partial flume or similar type of devices. Furrow cross section and spacing is measured at each section, and the rate of water advance and the depth of infiltration at each section is evaluated. So, infiltration from a furrow is determined by given this one your accumulated infiltration. Accumulated depth of infiltration is given by accumulated inflow at how much time, a particular time in a furrow the water has been introduced by stream. So, that will be accumulated flow, means stream size multiplied by the time, it will be the accumulated inflow, and then after measuring the cross section area and depth of flow, that will give the accumulated storage. So, accumulated infiltration depth is accumulated infiltration which we are getting from here divided by weighted area of the test section. This will give the depth of infiltration. Maximum non-erosive stream size. So, maximum non-erosive your stream size is given by q m equal to 0.60 divided by s, where s is slope of the furrow. This is an empirical relationship which is adopted, and then one can also find out what is the depth of water applied during irrigation. So, this can be given by equation that average depth of water applied during the irrigation d is given by q is the stream size which is applied in liter per second, and then multiplied by t, w is the width, furrow spacing means between two furrows what is the spacing and length of furrow, and 360 is unit constant. So, depending on the unit which we are using, the 360 will be used. Corrugation, it is just means these are small furrows, and here the smaller depth of water is applied. So, these corrugated furrows are constructed to direct water flow down the slope, and these are used for irrigating non-cultivated crops, close growing crops such as small grains or pasture growing on steep slope. It may be in conjunction with the border irrigation on land with relatively flat slopes to help in obtaining uniform coverage with water. So, corrugations can be made by using simple bamboo corrugators or by using cultivators equipped with small furrower or similar implements. So, these are the small furrows which are known as a corrugated furrows for pasture or grass or small grain crop that can be grown, we does not need. Sub irrigation is another method where water is applied below the ground surface, and by maintaining artificial water table at some depth depending on the upon the soil texture and depth of plant root. So, what we are seeing here, suppose the plants are you are seeing here plant, this is the root system and then there exists an water table. So, water movement it takes place from the water table to the root zone of the crop by capillary action. So, this controlling the water table, control of water table, it is done scientifically, and then water. So, means it is not feasible at all the places, but there are some certain places where the water table can be controlled. So, there is a control structure what we are seeing here, this is artificially made control structure, and when we want to raise the water table. So, with the help of control structure means there is water supply, it will cause the rise of water table, and then when the water table it goes higher, then we will regulate the water supply and then it will go as a drainage. So, supply as well as drainage is controlled artificially. These are very special kind of situation and are in natural conditions, such situations exist in our country. So, water reaches plant root through capillary action, water may be introduced through open ditches or mold drainage system. This method requires a special site condition. This is what I am telling, that it needs a special site condition to have complete control on water table. Now, so far I have discussed about different methods of surface irrigation. We will be entering into the micro irrigation system. Why micro irrigation system should is emphasized? Let us try to compare with the existing conventional surface irrigation methods. So, one indicator in terms of water saving. So, in conventional irrigation system, we waste lot of water. When the water is applied over the land surface, losses occur due to percolation, losses occur due to runoff, losses occur due to the evaporation, which is possible with the help of micro irrigation system. You are giving just 40 to 70% of water, it can be saved over conventional irrigation system. Runoff and depercolation are negligible, or there is no such type of thing provision are not made. So, there is no provision for percolation loss, there is no provision for surface runoff. Water use efficiency, from a water use efficiency point of view, we see in most of the irrigation project, and then it is when it is means combined with the surface irrigation system, the hardly we are able to get irrigation efficiency up to 50%. When it is efficiently managed irrigation project with surface irrigation, hardly we are able to get 50%. So, the huge amount of water it goes as a loss, whereas in micro irrigation system one can achieve the water use efficiency up to 95%. There is saving in labor engaged per irrigation is higher than other methods of improved irrigation system. So, here and then labor required only for operation or periodic maintenance in case of micro irrigation system. As far as the surface irrigation, when we come to the different soil types, so percolation is more in case of light soil, in case of sandy loam soil, and when it comes to the heavy soil or clay soil, runoff takes place, whereas in micro irrigation system it can be applied to variety of soil, all types of soil, and so that is another added advantage. And then besides this, there are many other added advantage, that when you are applying water in conventional irrigation system, it is taking time to reach to the end of the field, whereas in micro irrigation system entire field can be instantaneously, it can be brought under irrigation system. So, in a shorter period we can complete irrigation process as compared to surface irrigation. So, let us summarize this lecture. We discussed about different methods of irrigation. These methods, surface irrigation methods, were border, check basin, furrow irrigation methods. We discussed about hydraulics of surface irrigation. We also discussed about comparatively the different how these conventional irrigation system and micro irrigation system, how what is the comparison in different performance indicator, and then we will be now entering in forthcoming lecture in the micro irrigation. You can refer these books for this particular topic, and also you can refer internet references. And so, thank you very much for your patience hearing.